Welcome back to Calculus 2. We are going to talk about the second part of the improper integral, section 7.8. We need to talk about the type 2 improper integrals. But before, let's just quickly review type 1. So we said that the type 1 improper integrals will be very easy to spot because the limits will contain either negative infinity or positive infinity. So type 1 is very easy to spot. In 1 second. So as we are looking at the type 1 improper integrals, we are going to see one of the infinities in the limit. And the way we deal with that is we replace that infinity with a finite value b, and then we set that b to infinity in the limit in front. You have to keep writing that limit over and over and over again in every step until you get to use it, which means that the last step will not have it anymore. There was some confusion with the terminology, which we usually take for granted that it's clear what it means. The words convergent and divergent. We are going to use this in every single problem in chapter 8 and some of the 9. So what is the meaning of the word convergent? Yes, come together to a value that it's fixed. So for instance, you solve the integral and you get a value like we had here, 1 over e. We will say that area is converging to 1 over e. The meaning of that is, and why we use that particular language should be clear if you look at the graph of e to the negative x. The graph of e to the negative x is leaking area forever to the right. Do we see that? Do we all see that? Yes, we do, right? So the area is leaking over there, and because of that, we cannot, because of that, we say the area will converge to a value. Now, if the area is not converging to a value, then we say it's divergent. Now, divergent, right, means breaks off, goes away, moves away, and so on. So that's the meaning of the convergence and divergence. So if you get a value, an answer that it's not infinity, you will say convergent. If you get infinity, you will say divergent. Technically, that's it. So type 1 integrals, type 1 improper integrals are very straightforward in respect that you get to take, you integrate, and if you get finite value, it converges to, the area converges to that value. If you don't get the finite value, if you get one of the infinities, we say it diverges. It's very straightforward to spot the type 1 because one of the infinities will be in the limits. Now we get to a problem where we say, what's the integral of 1 over x dx if we go from -1 to 1? So now, you might think, well, that's not a problem. Integral of 1 over x is ln absolute x, and when you plug in 1 and -1, they will just work. Everything will be awesome. No, 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 right? The issue is that there is a vertical asymptote there is a vertical asymptote at x equals 0. And that is a big problem, an issue. Because if you look at the graph and you say from -1 to +1, you are talking about this area which is going to leak this way and this way forever. Now we know from previous cases that even if the area is leaking forever, you might have a convergent value, right? It was this problem here, which clearly had a leak right there into infinity, but still the value is finite for the area. So now, for type 2, we'll have the vertical asymptote, and the area will be leaking instead of horizontally, now vertically, following the asymptote. So what are we going to do? Well, to solve this problem properly, we have to break it apart into two problems. And each of the, so clearly there is an asymptote at 0. And then replace each one of those with the limit problem. So limit, 0 is at the upper, which means we are replacing 0 with b. Plus another limit. And this time a goes to 0 because it's on the bottom. What's the integral of 1 over x? ln x. Well, it's close, ln absolute x. So now what we do is solve these. Limit b goes to 0 of ln of b minus ln of absolute -1 plus the limit a goes to 0 of ln 1 minus ln a. So all I did is I plugged in the upper and the lower limits to compute each one of the two integrals. Now, two of these go to 0 because ln of 1 is 0, the x-intercept. And then we have ln at 0. Well, that's negative infinity. Since this one over here is negative infinity, yes. So this one over here is negative infinity. This one will also be. So as long as one of these happens, immediately diverges, and that's all. The graph. Yeah. If I graph the ln function, this is ln x. If you are going towards 0, you see that this tail end goes down to negative infinity. All right. Divergent. Yes. It's infinite area. That's all it is. It's infinite area. What happened? Yeah, approaching from the left, approaching from the right. We can put plus here because it is approaching from the right. Yes.
Is it safe to say that ln of a goes to positive infinity because it's negative?
Yep. They don't cancel though.
Huh?
They don't cancel.
They won't? Just because they go different ways, so it just becomes different. Gotcha.
Let's start with the cheaper example. There it is. Try it. Do it.
Let's describe from positive infinity at 0. Is the graph of that equation without positive
Well, we don't actually have to consider the graph because we immediately see the denominator, right? We know that e to the any function of x will not dip below x-axis, right? Because the exponential function is always above, which means that you don't get. It's just what's the denominator doing, unless you have functions that have vertical asymptotes built in, like tangent. Well, that's still trig functions are still sines and cosines in the denominator. It is ln x, for instance, right? So ln x, if it's in the numerator, still has the vertical asymptote of 0, right? So that's a scalar function. But any composite functions like this, if you have the denominator, whatever denominator is 0 is a problem point. So maybe it would be worth for me to note this before. I'm going to write it on the board, and then if I remember, I'll do it again on a tablet at some point. If you have the integral of 1 over x dx, this is clearly the issue at 0, right? But look, if I say 1 to 3, hey, it's a Calc 1 problem, right? We're good, because there is no asymptote from 1 to 3. So whatever you find as area from calculus 1, that's it. You're done. And accompanying graph right here from 1 to 3. So you can see everything is bounded perfectly, no issues. Same problem, 1 over x dx, but you switch from 0 to 1 and all of a sudden all the hell breaks loose, right? Because 0 is the vertical asymptote and you get this area leak, right? So now you're talking about this area here and the area is leaking right there.
which is improper integral. This is why I mentioned yesterday that this section 7.8 is fundamentally changing your life from this point on. Every time you see a definite integral, one with limits, you will first have to stop, like freeze, and make sure, I mean, don't freeze on a test. Just, take it, look at this and say, is there an asymptote between these two numbers? So this improper integral type 2 can lurk within any definite integral from now on. Those that you saw in Calc 1 are all carefully crafted, right? We as instructors and professors, we take care in making sure that you are not asked this question in Calc 1 exam, because you can't do it, right? But now, if I ask this, you go, thank you for the gift. If I ask this, well, you show off your Calc 2 math skills, all right? Welcome to Calc 2. So now we know that because this root x is in denominator here in this current problem, when is denominator 0? At 0. So that's the bad point. So we start the problem with limit a goes to 0, and then you do the rest. Now integration technique inside is whatever works. You go, is it basic, right? Is it diffuse sub? Is it partial fraction? Is it trig sub, right? You have to go and ask yourself those kind of questions. Do this. No, these for the palms. And they so anytime you replace the bottom number with a, and then we need to go into the number that you're replacing. These values don't have to do anything.
He is right. That's 7 today. That's going to be the correct. On that one. 1/2 times minus 1. It becomes a. And you just lose the outside.
We only have one column. Yes.
Are you sure this is? I thought it's one gets moved to the outside. It's one. Well, not with use of that. Well, you're changing it. Well, yeah. Make this U. Oh, I thought you were talking about. No, it isn't. Because du is 1 over dx. So, if it was to separate this or rewrite this in the equation, it would be e to the u times 1 over u. Du is here, so du is equal to 1 of this dx. You get what I'm saying? So this would be b. You get what I'm saying? Because there's a denominator. Alright, so let me break up this problem. I explained it here. So you agree, right, that this is equal to e to the x squared times 1 over this, right? Okay, so this is du, this is u. Wait, no. E to u. That's it. One second. So you make u a square root. I just rewrote it as 1/2. So when you do the derivative of it, it becomes x to the negative 1/2 over 2. When you do the derivative. And then when you rewrite that, it's equal to 1 over 2 square root of x. Then you have to do something with this 2, then I'm like, do you just move it out or do you divide it? And that, and that's why I'm confused. If you divide it up, then it becomes 2 times the integral of 1/2. Either way, you're left with this, which is 1 over the square root of x, dx, which is equal to du. Yeah, so you move equation. Yeah, you see? Yeah, but it's not 2 over, so that's why I can't just take the 2 out. Wait, do you pay original? When you you're using do you divide that out so outside of the integral means 1 over 2 or is it 2? It just goes to, alright.
I usually write it out, like I have whatever, and then I write
You can literally go in and you can actually cross it out. No, I'm saying, so I'm here, right? Oh, so. Oh, so you solve it for yourself.
Exactly, you solve. Let's take a look at this problem together.
What happened? What was the question? That's the answer. So let's see his exact answer now. So we were going to start this problem by noting that we have a bad point at 0. So 0 is the one that I have to replace. Since 0 is the lower limit, I will replace it with a. So we're going to go a goes to 0, and then integral a to 1 of e to the root x divided by root x dx. We are going to use u sub now. U equals to square root of x, because we know we can integrate e to the x, right? So you are replacing all of that square root of x with one variable u, and then du is equal to 1 over 2 root x dx, which is awesome. So if I just fix this with a 2, and you can put 2 in front of the integral or in front of the limit, it doesn't really matter. Now we get the limit a goes to 0, 2 times the integral. So the entire thing over here is going to be du. So we have e to the u du, and that's it. We good? Now, what's happening with limits? You will take a instead of x, right? So it's root a, and then you will plug 1, and you will still have 1.
Why does it become root a?
When you use the transformation to go from x domain into the u domain.
Okay, gotcha.
So the lower limit used to be a, you plug that in, and you get that u is equal to root a. So now, we integrate, and we get e to the u from square root of a, 1, and one more limit. You can kick 2 outside, in front of the limit, it's okay. And you have e to the 1 minus e to the square root of a. So now we have 2. Limit as this one goes to 0 is 0. So 2 times e, which is just 2e. Are we good? Which one? This one? You have a 2. Right? That's that 2. And then when a is equal to 0, oh wait, when a is equal, it's 1. So it's just e minus 1 here, like this. Yeah, 2e minus 2, or yeah, that's good. So when you plug in 0 here, you will get e to the 0. E to the 0 is 1, and then e to the 1 is e.
And that converges to that equation.
To a number, not equation. 2e minus 2 is number.
Okay.
So there are going to be problems where indefinite intervals or more than one mass asymptote. For example, if you have like.
You mean vertical asymptotes?
Yeah.
Sure. You can have a problem with infinitely many vertical asymptotes called tangent, right? So tangent, we know that the principal tangent, right, is between negative pi over 2 to pi over 2. But what happens if I'm asking for the area for the tangent that goes from 0 to 2 pi, right? You will have 3 vertical asymptotes.
So we have problems where we have to find
Split.
like multiple limits then.
You will have to split. Yeah, but not on the test. Yeah, you get the idea. Now, can we mix type 1 and type 2? Sure, right? Because as you can see, this problem here has problem at square root equals, at x equals 0, right? So this problem, if I want to mix both of those concepts, goes from 0 to infinity. And you have problem on both ends in that case, right? 0 to infinity. So you maybe want to split the integral 0 to 1 and then 1 to infinity to apply exactly one of the limits and one of the rules, type 1, type 2, on each one of the parts. That's how awesome this section is, right? You want to share my enthusiasm. I see.
What do you do when it's like say 0 to infinity? Because then there's like an issue if it's e to the infinity power.
Yeah.
Don't that go to the e? No. That
Goes up.
It'll just be infinity minus.
Yeah.
Okay.
Let's make sure it works. Sign. All right, one more. So procedure is always the same. Figure out where the problem point is, where the vertical asymptote is, and then just make sure that one is in the limit. Do the integral whatever way you can, /no, and that's it. Let's take a look at some of the awesome problems that you will definitely hate. Should we do a 30-minute problem? Yeah, why not? You signed up for the class. You'll love it. All right, I'll be back in like 30 minutes. What happened? Oh, trick solve. Okay. Yeah, you gotta set it up. Now, what can you see there? Anyone? Denominator goes to 0 when? 2 or negative 2. So both ends are problem points. So now what? Break into two integrals. Negative 2 to 0 with the whole thing, and then plus 0 to 2 with the whole thing, and each one gets its own limit, and then go. So yeah, you get the idea.
Thanks, Professor.
Yeah. Good stuff. To solve the integral. Improper. Why is it wrong? It's annoying. It takes forever. So much fun. You guys give. I'm just gonna prove this.
I don't give up. Us Apple guys never give up.
How did you figure out? Good.
I think so. I think I set it up. Did I set it up correctly though?
No, I haven't done a problem. Yes, it's awesome, right?
Alright, stress right.
I mean, it's impossible to calculate, oh my god. But technically, have you calculated when you do trig sum, you have to solve the trig integral, right? Go back then to the trig limit. I'll be back in like 30 minutes.
way I set up my triangle. But it's hard to explain. And remember, this is yes, I did it wrong.
Yeah.
So the derivative of sine is cosine. Yeah. So that makes it super easy. I just you think you're doing something wrong, but it's actually something really easy.
Yeah.
Yeah. Which is just x.
No, wait,
Two. No.
Oh, multicolored stuff.
Yeah. So this just withdraw on. Yeah.
Okay, I was about to say that what you're saying people now. I always feel that way, like when like talking to people doing like things like I always think oh my god, I know you do. And I actually usually I just fall about
Converges to zero.
think I'm the
Yeah, I got converges to zero.
I didn't finish it. I don't know yet.
Alright.
yeah, that's zero.
Yeah, zero.
Yeah, the limit
That's negative. So I think plus 0 minus 2, which becomes 2 minus 2, which is 0.
A is 0 and then E is 0 B. It's all negative 2 and negative x. That's 2 plus then you plug in 2B. Oh wait, I have 4 then. I have 4.
So we have
Oh, yeah.
0.
Hey, I have fire.
Boss has pi. Pi. Oh, gotta be pi. Let's see if I can reproduce pi.